Welcome back everyone to Data Science for Everyone. Today we're going to be looking at k-nearest neighbors. Now k-nearest neighbors is an extremely nice and simple algorithm. It's very easy to use and it's a supervised learning method that is used for both classification and regression problems. So let's get started with using some of our basic imports. So import pandas as PD, import numpy as mp, import seaborn as SNS, import matplotlib, pyplot as PLT, and then let's also set our matplotlib to inline. Now we also want to grab a hold of our data. So this data set is going to be a CSV file, and we also, this is what did I name this? I think it was classified data. Okay, let me copy the path there. Now, I actually don't need that. Now, with this data, actually, if we just take a look at it here and do df head, we'll see here that actually this has this unnamed column in here, and so we actually want to turn that, get rid of that, and so here we can say something like index column is going to be 0. It's that first column there. And so now if we take a look at it, notice here it got rid of our untargeted there, and we have now just our basic index. That happens a lot of the times when people have exported the data and they didn't know, again here, if you can set this to any column that you want, if you know what your index is going to be. So now let's start with looking at standardizing our variables. So let me put a little bit of a note in here. So when we talk about standardizing the variables, okay, K&N classifiers predicts a class of a given test observation by identifying the observations that are nearest to it, okay? So we're talking about the scale of that variable is definitely going to matter, okay? So being a scale here, for example, maybe you have some variables that are, as we can see in our example here, we have like -1 or 1, 1.2, and this one maybe 0.5. Some of these we want them to be between. When we scale, we usually want them to be between 0 and 1, or -1 and 1, depending on what type of standardization you want to do. Now, any variables that are on a large scale will have much larger effect on the distance between the observations. Hence, we have this KNN or K-nearest neighbors classifier. Then again, that is something on a smaller scale. So again, you want to put all of your variables on the same scale so that they are comparable, is basically what we're talking about here. So from scikit-learn dot pre-processing import standard scalar. So then we're going to instantiate our scalar here, and then we will have our scalar dot fit. And we need to get rid of our target class. What was that? Target class. Target class, and this is access is 1. Okay, that has been scaled. Again, so what we did here is this scaled everything except for our target class because it's a probably, I don't know if this, I'm pretty sure it's a binomial class here. So let's also look at here then, let's create our feature vector. Let's do scaled feet for features. So we have our scalar dot transform here, and we want, again, this same thing we have here down there. So these are our scaled features. Now we want our data frame features here, and so we want PD dot data frame, and then we want our scaled features here, and then the columns to this so that they have their name is going to be df dot columns, and then we want here everything up to but not including the last name here. Okay, so we're dropping this target class, and we can actually take a look here at that scaled feature so that you can see it. Notice here that this is actually NumPy array. Okay, and that's why we're wanting to convert it back to a data frame for us. So we can take a look now. Head, and notice now we actually have everything that's been properly scaled for us. So the next step is using our train test split. So train test split the data. And again, we're going to want to predict whether someone is in the target class or not. So in this instance, then we'll start with something like k is equal to 1. So from scikit-learn, we want neighbors. Whoop. What's going on? Neighbors import, and we want k. Whoops. Yeah. K nearest classifier. Now, whoop. What happened? Oh, whoops. Because I have a T in neighbors. So one thing is that this is here we see we were doing the k nearest neighbor classifier. Now we are doing the classifier, but we could also do the regressor as well, depending on what you're wanting to do with the k nearest neighbors. Again, it's mainly used for classification purposes, but again, people use them for all sorts of things, usually particularly as a benchmark for regression training. So here, oh, whoops, I also forgot to train test split. I got ahead of myself here. This is actually for, whoops, using KNN. So let me go back and do the train test split because I got a little ahead of myself. So from scikit-learn dot model selection, we're going to import train test split. So then let's do our train test split here, and we want to go through and grab the little helper copy here, and let's get rid of this. Whoops. So let me change this up here, and we want our df features, and our y here is going to be df here, and we want target class. Okay, so let's see, what do we want to do with this? Okay, so let's go on and now put in our, we'll instantiate our model. Now we want our in neighbors to be 1. Okay, so that's what we're going to start out with. And then we can kn in, and then here we can do fit. We want our x train, we want our y train, run that. And again, we're just going to be using the basics here. Let's do a prediction of our model. Predictions, we do knn dot predict, and then here we do x test, run that, and then let's do our prediction and evaluation. Okay, so we're looking at evaluating our model. So for these models, we use a classification report, just like with other classifiers that we've done in the past. So let's do import classification, whoops, report, and we also want the confusion matrix. So let's take a look at our confusion matrix first, looking at y test, and then our predictions here, and we see that we're doing okay. Again, a majority are correct in here. Again, we have 11 errors here, 9 here, but that's not too bad. But now let's also look at our classification report, and let's take a look at our y test here and our predictions as well. Again, now we're looking and we're doing pretty good. We have a 94% confidence interval here. Now, the one thing that we are looking at here, again, we did this confidence of, or this number of neighbors is 1. again, this is usually not necessarily the best thing to do, okay? We need to be able to find out which k value is actually optimal. So let's go on and look at how we actually choose a k value. Okay, so what we're actually going to look for, I usually like to look and use the elbow method for a good k value. So let's write up a little bit of a function here. So to save on our error rate. And then we're gonna, may take some time. Okay, so but we do for I in range, and let's say from 1 to, let's just do 40 for now. KNN is equal to kneighbors classifier here, and then we have our neighbors, and it's going to be I, so this will run for each of them. And then we have our prediction of I, and we want this to be KNN, and then here we do dot predict, and we have our X test. Then we also want, oh, whoops, these are our predictions, but we need to make sure and fit in our classifier with our X train and our Y train in here. And then the next point that we want to look at here is take the error rate dot append, and we want to do the mean here of our prediction of I, where it's not equal to Y test. Okay, so this is going to give us the average error rate that we're wanting in here. So we can run this now. And again, this may take a little bit of time depending on your machine. Okay, so just be thoughtful of that. So let's plot out. Well, let's take a look at our data really quickly. Okay, and you can see here that we have our error rates here. And the goal of this is that it should be kind of going down, and it should kind of peter out a little bit. It just depends on the data itself. But let me clear that out. We don't really need that. And so let's plot this out. So we'll do plt.figure. And what do we want here? Let's make this, let's change the size. Figure size, let's do a 10 by 5. Okay, and then let's actually plot this out. So we want plt.plot. We want our range, again, so from 1 to 40. And then we are going to have our error rate. And then we want the color. Let's make this blue. And I want the line style to be dashed. The markers, let's make it what? What do we want to make it? Let's make it just a dot. And then we want our, let's change our marker color here to marker face color. Let's make it to red. And then we need to make our marker size bigger. Marker size is equal to 12. Okay. Then what do we want on this? plt.title. Let's give this an error rate versus k value. And then we want plt.xlabel here, and let's do k, and then plt.ylabel. Again, you could do this in a couple different ways if you wanted to. We can even do it with scikit-learn, but I think it's nice to have everything kind of explicitly done here. Whoops, and what did I mess up on? Oh, markers. Oh, it's marker. There we go. So again, we see here that this there is a little bit of an issue in here, okay, where it really starts to drop, okay, and then it kind of has this little hopping around all over the place. But we kind of want to try and find, for example, like if we see here that around, I don't know, k is, what do we have here? This is like k around 4.5 or something like that. And we can actually kind of mess around with this. You kind of want to find that minimum point where it starts to kind of bottom out. This here, it has a little bit of a hump. And then it kind of starts to go back down again. So we could try a couple different ones. We could do something like maybe, I don't know, what is that, 12? And then there's another hump here, but let's do this. Let me maybe rerun and just double check everything again real quick. So everything, I was just double checking everything a second there just to make sure that everything looked okay. So let's go on and maybe try with, let's try this little, maybe this elbow point here of what do I want to look at? Let me look at it real close here. Let's try here at maybe 12 or so, just to see how that looks. So let's give that a try. So let's do KNN. We have our k nearest neighbors classifier, and we have this k neighbors is equal to 1. Let's go on and actually change that up to 12, and we can scroll back up to look at the previous. This is our previous precision metrics here. Let's do 12 and do knn.fit. Here we want x train, we want y train here, and then we want to predict here, knn.predict, and we want this on x test. Oh, and you know what? I will wind up accidentally overriding that. Let's do 12 here. And then let's do print. And we have our confusion matrix. X test. Pred, and we want this to be 12. And you know what? Let me just cut this, run this, and put this here. Okay, and actually, let's see. They are very similar, but it is a little bit better. Okay, so when we're looking at our predictors here, you can see here when we look at the errors are smaller. Okay, so then now let's double check on our classification report here, and we want our x test with our predictions for the 12. And again, you can see here that overall it's doing a little bit better. Okay, and I would say that that is definitely a good result to get there. We could also play around with it, maybe doing something at 30 as well to see. And let's actually go in and do that just to see how it goes. I don't know if it'll be better or worse or not. But let's give it a try just to see. Again, I would suggest probably sticking with the lower number, but again, just for fun here, let's actually go in and try and see how it did. So then here, and let's go in and grab this one, and we want this one here, and this is 30, and here 30 as well. And they kind of switched out a little bit, but overall there's not really much difference between having k is equal to 12 or k is equal to 30 in here. Again, you guys can play around with it a little bit more just to see how it goes. But that's all I have for you guys today. If you like this, please make sure and comment, subscribe, and click that like button. I'll see you guys next time. Bye-bye.